of Physics Psychics. I am Jessa May at your service and my science Nazi partner, Edward.
Hello dear listeners! Are you ready for another lesson? What are you waiting for? Get your papers and pen to scribble out the important details of our topic for today.
But before we formally start, have you ever wondered why is it so difficult to wake up in the morning and it's very easy to get a 14 hours straight of sleep?
Well, I don't think it has something to do with our topic, you know.
You bummer, that's a joke.
Haha, that's a corny joke. But anyways, we should proceed. I think the right thing to say is why is it difficult to stop when we're running too fast? Or why is the wheel keep on moving but when it collapses with the wall, it stops?
That's quite obvious. But here is another question. Why does the paper fall slowly compared to a pencil? And why does the ball bounces back if it falls on the floor? I know that you people know how to describe this scenario, but how about explaining it scientifically?
Yeah, that's right. It is somewhat a general knowledge that even a third grader knows. So why do we tackling this if it's general information?
Because this is a science show and it's our job to explain things beyond our naked eye.
Oh, well, Jessa, right this time. For the audience, do you already have in mind or a guess on what is our main topic for today? So without further ado, let's start.
So for today's episode, we're going to talk about the three laws of motion by Sir Isaac Newton. I'm sure that most of us are familiar with this scientist, right? If not, then who do you think this guy is?
Well, Sir Isaac Newton is one of the famous scientists out there, a cool dude with this weird hairstyle that is known as a man who happens that an apple fell up on his head. His work, Philosophiae Naturalis Principia Mathematica. Or in English term, it is the mathematical principles of natural philosophy, which is published in year 1687, that plays a great role in the enlightenment of the people in Europe. This book established the laws of motion and the universal gravity.
It seems that Edward knows a lot about him. So let's move on to our main discussion, the three laws of motion. Well, let's define first what motion is. According to the dictionary, it is an act or process of moving. In other words, it is anything that is moving. Moreover, the study of motion is called kinematics. And before I forgot, today we have our guest speaker to explain us the concept of three laws of motion. Please welcome Dr. Eliza Marie Murillo.
Good day, everyone. Thank you for guesting me here.
That's not a problem, Dr. Murillo. It's such a pleasure for us for accepting our invitation. Because for today, we need your help to explain this for us, with the audience, to have a better understanding in three laws of motion by Sir Isaac Newton.
Well, to start off, the three laws of motion have their own names. This is just not called as the first law, second law, and third law. The first law is called as the law of inertia. The second law is called as the law of acceleration. And lastly, the third law is called as the law of interaction.
Kindly explain to us what does these laws states.
A few minutes ago, I am actively listening to the both of you. And you mentions about running fast, then wasn't able to abruptly stop. And the other one is when the wheel moves constantly until it stops because of the wall. The answer for these questions are indicated in the first law, or what we call as the law of inertia. It states that an object at rest will stay at rest and an object in motion will remain in motion in the same speed at the same direction unless acted upon external unbalanced force. Basically, this is what inertia means, because it is a property of a body to persist in its state of rest when at rest as the same as if it is in motion. Inertia is also equal to the mass of the body. So the greater the mass, the greater its inertia. Let's say, for example, a cabinet has a greater inertia than a chair because a greater force is needed in cabinet for it to move or change its state. An object will be uniform acceleration unless it is intervened by an external force. Just like what happened to the ball, it stops when it collided to a wall. There are two parts of this law. The first part is the inertia at rest, which means that if an object is at rest, it usually exerts a downward force that makes it stay and still. And aside from that, there is no net force acting upon the object, that's why it stays at rest. For example, a box on the table exerts a downward force while a table exerts a force opposite to the box. Since they both exerted force equally and in opposite direction, this means that there is no net force and implies that a force is needed to move the box. The second one is the inertia in motion. Basically, an object in motion will move constantly in the same speed and direction when the ball moves at 2 meters per second, and it will continue to move in 2 meters per second unless there is an unbalanced force present that will make it stop or it will accelerate and turns into different direction.
Wow, that's just the first law, and it got me overwhelmed with information. How about the second law?
Okay, let's move to the second law, or the law of acceleration. It states that the net force is equal to the product of mass and acceleration. In other words, the acceleration is directly proportional to the force exerted. The equation that represents this law is F is equal to ma, where F is the force, m for mass, and a for acceleration. If we analyze the equation, we can conclude that the greater mass, the higher the amount of force needed. If we're going to derive a formula in order to get the acceleration of an object, we're going to divide both sides by its mass. Then we will get the formula of acceleration is equal to the force divided by the mass, or A is equal to F over m. The new formula that we got pertains to the greater the mass, the lesser its acceleration. In this case, the acceleration and mass is inversely proportional to each other. On the other hand, the most common case of net force making something move is the gravitational force. Let's say, for example, that we threw a two different ball in the air, and the one is inflatable one, and the other is a rubber ball. If we threw it using the same force, we can calculate the force of gravity acting upon the balls, since we have a constant number of acceleration due to gravity, which is 9.8 meter per second squared. We can now solve the force of gravity on the ball. If the inflatable one has the mass of 0.2 kilograms and the rubber ball has 1.3 kilograms of mass, then the force of the gravity in the inflatable one is 1.96 Newton, while the rubber ball has 12.78 Newton. These values are what we call the weight, and the unit that we use for this is kilogram meter per second squared, or newtons, with a symbol of capital N. Obviously, the one that will land first is the heavier one. Gravity is not the only force that can be acted upon an object. In calculating the net force, there is more than just the gravity, and that force will be explained in the law number 3.
That's a lot of information to take. I think we need to cut it in here and give our audience a short break so that they won't break down in analyzing the concepts. So, we'll be right back after this short commercial.
Magandang araw mga kakosa. Ngayon ay makakarinig kayo ng mga matitinding pick-up lines. Banatan mo, Aling Shoni.
Para kang bomba ko rin. Bakit? Kasi ang lakas ng putok mo eh.
Wow!
Hello, Tipay.
Shoni, may tanong ako sa'yo. Tao ka ba? Bakit? Wala, naninigurado lang.
Tigil mo yan!
Hello, Tipay.
Wow! Oh! Oh!
O Koring, mangga ka ba? Bakit? Kasi mukha kang kalabaw eh.
Wow!
Hello, Tipay.
Wow! 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 Wow!
Tantos ka ba, Shoni? Bakit? Kasi bibinggo ka na sa akin.
Wow! Wow! Wow!
Hello, Tipay.
And we are back to discuss the last and third law, so keep tuning in.
Finally, we came to the third law of Isaac Newton, which is the law of interaction. It states that in every action, there is an equal and opposite reaction. In this case, the forces do not cancel each other because two objects or bodies are involved. A force is applied on one another and the other applies the same force opposite direction to the first. Let's take the ball as for example. If you drop a ball to the floor, it will bounce, right? Or, if it depends on what type of ball or what surface, it still goes up a little. Another example, a man that is paddling a boat. You paddle it backwards so that the boat will be moving forward.
Well, thank you, Dr. Murillo, for sharing such an information. I hope that our audience understands the concept of our topic for today.
Right, what a knowledge that we got. It is absolutely awesome to think that we already knew the technical definition behind the once known as general information.
Yeah, but sad to say, another meaningful episode has to come an end.
But before this comes to an end, I would like to leave a hanging question to you guys. What are the things that we usually do that we don't know that is the real life application of our topic today? And lastly, a bit philosophical one. How does the motion of your life goes? And why do you say so? Anyways, again, I am Jessa May.
And I'm Edward, that will always remind you that there's a complex meaning behind everything. We're turning out. See you next episode. Goodbye!
Goodbye, guys.
Are you tired of your dirty kitchen floor? Well, how about your nasty tiled bathroom floor? Well then, there's no need to wait, because now we introduce Glorious Map! Glorious Map is a very useful map that will make your dirty floor cleaned at no time. It has its wonderful handle for an easy and non-tiring grip, and an absorbent foam that is so easy to clean. Isn't it a catcher? So what are you waiting for? Glorious Map! A super wife needs a super tool.